Hey kids, Flexing Teacher Weber here with another video on solving linear math equations. In our first video, we looked at a couple of word problems where we could develop a math equation from the word problem. I want to look at just more equations in general in this section and practice solving them with the idea of equality. This is a topic that you might have touched on a little bit in remote learning last year, but you might not have touched on it a lot. So we're gonna attack it like you haven't really seen it before. So the idea with solving a linear equation is you want to show what is done to both sides of the equal sign to show the value of the variable. So if you're in number one, I want to show the value of the variable x. This is some number plus 7 equals 1. And I want to isolate this x on one side of the equal sign so that it shows what the value of x is. So the way I do that is I want to make this positive 7 turn into 0. So I do the opposite of positive 7, which is negative 7. So I'll do negative 7 there. And in algebra, whenever you have an equal sign, you can do any number operation to one side of an equal sign just as long as you do the same thing to the other side. So if I subtract 7 there, I have to subtract 7 there. Working down the page, if we simplify what's left, this turns into 0, which is what we want. And we have x equal to positive 1, negative 7. That works out to negative 6. Pardon me. Now, the next thing we want to do is actually check that this is true. So we'll do a check. So we'll check this. We'll start with the original equation, x plus 7 equals 1. And we will substitute in our answer for x. We got that x is negative 6 plus 7 equals 1. Now look at this statement. Is this situation true? Does negative 6 plus 7 equal 1? Absolutely. Both sides of our equal sign are the same. So we know our answer is correct and our equation is correct. Check. Let's do another one. All of these things are done exactly the same. It's just sometimes the equations are set up a little bit differently. So 8 plus y equals 4. Well, I want to show the value of y. To do that, I'll want to get the y by itself on one side of the equal sign, and I'll do that by taking positive 8 away by subtracting 8. And if I subtract 8 on that side, I have to subtract 8 on the other side. Now, positive 8 minus 8 goes away, and I'm left with a positive y. But just like integers, if we have a positive sign in front of a variable, we can just say that that's y. And then positive 4, negative 8, the signs are different, so I subtract. And since I have more negatives, I have negative 8 and 4 positives, the answer is negative. Check it now. Here's the check. Write down the original equation, 8 plus y equals 4. Substitute in your value for y. In this case, we said y is negative 4. So this statement should be true then. Does 8 plus negative 4, does that equal positive 4? And it does. So we'll say 4 equals 4. Since both sides of the equation are true, it's correct. So all of these questions are done exactly the same. There's just different integers to worry about. Let's take a look at this one. Number 3, negative 12 equals 14 plus x. This time, the variable x is on the right-hand side of the equation, but we still do everything the same. Find the part that's beside the x. It's positive 14. I want to make this x by itself, and the way I'll do that is by subtracting 14. And if I subtract 14 here, I have to subtract 14 there. Now let's take a look what I have. This will be weird because everything's backwards, but we're just working left to right on our paper. I have negative 12 and negative 14. The signs are the same, so I add them and use the negative sign, negative 26. equals This turns into 0, which is what I want, plus x. And if we have a variable with a positive sign in front of it, we can just think of that as x, which is exactly what we want. So negative 26 equals x. Now let's check it. When we check it, both sides of the equation should work out the same. So write down the original equation. I've been doing all my checks in a different color just so you can see the difference. Okay, just keep working down the page and replace your variable x with your answer that you got. In this case, it was negative 26. Now check, is that true? Does 14 plus negative 26 equal negative 12? Well, these signs are different, so we subtract. And we have more negatives, so for sure, both sides of the equation are true. Negative 12 equals negative 12. Check. Okay, last one from this set. Another one where the variable is on the other side of the equal sign. 21 equals x plus negative 3. So I want to get the x by itself. I want to make the negative 3 go away, and the way I do that is by adding 3, because that will turn it into 0. And if I add 3 on that side of the equal sign, I have to add 3 here. And again, it'll look strange because everything is backwards, but we just work left to right. We just go this way. Well, 21 plus 3 is 24 equals x. Negative 3 plus 3, cross out because they're 0, and that's exactly what we want. We want the value of x by itself. 24 is equal to x. Okay, let's check it. Check it. 21 equals x plus negative 3. 21, replace my answer for x, and that was 24 plus negative 3. Now, is that true? Does 24 plus negative 3 equal 21? Absolutely. So since both sides of the equal sign are the same, we're good. So we're solving and checking math equations right now. Let's do 4 more, get a little bit trickier. Okay, number 5, m take away negative 6 is negative 4. Now again, we want to get the m by itself, but beside the m, we have this tricky situation here, m minus negative 6. Well, if we remember back to integers, when you are subtracting a negative, that's the same as adding a positive. So think of this as m plus 6 equals negative 4. And now do what we were doing before. I want to make plus 6 go away, so I have the m by itself. The way I do that is by subtracting 6. And if I subtract 6 there, I have to subtract 6 on the other side of the equal sign. Okay, I still have m. This goes away, which is what I want, equals negative 4 and negative 6. The signs are the same, so I add them. And that's negative 10. Let's check it now. So I'll use the equation, this one right here, m plus 6 equals negative 4. And I'll replace the m with my answer, negative 10 plus 6 equals negative 4. Now, is this true? Negative 10 plus 6 is negative 4. Since both sides are the same, we are good. Okay, this question is exactly the same idea. J minus negative 7. Well, take the time to rewrite this as j plus 7 equals negative 8. You want to get the j by itself. You want plus 7 to go away, so you do the opposite, minus 7. And do it on both sides of the equal sign. So minus 7 on that side, minus 7 on this side. Okay, plus 7 minus 7 goes away, and I'm left with j equals negative 15. Check it. Write down the original equation. I'll write down the j plus 7 equals negative 8. Replace the j with negative 15, our answer. Plus 7 equals negative 8. And is this situation true? Does negative 15 plus 7 equal negative 8? Absolutely. Negative 8 equals negative 8. Both sides of the equation are true. Pardon me. Two more questions to look at. So number 7, x plus negative 8 equals negative 2. I have a plus negative 8. I want to get the x by itself and have negative 8 turn into 0. So the way I do that, add 8. And when I add 8 there, I have to add 8 on the other side of the equal sign. So when I do that, working down the page, I still have x left, but minus 8 plus 8 goes away. I still have a plus sign there, but that doesn't really affect anything. And on the other side of the equal sign, I have a negative 2 and a positive 8. The signs are different, so I subtract, and I have more positives, so the answer is positive. When I do my check, I write down the original equation, x plus negative 8 equals negative 2. Replace my x with my answer 6 plus negative 8 equals negative 2. Is this true? 6 positives and 8 negatives add up to negative 2. It is true. Check. Okay, the last question, a little bit different. 5 minus x equals 10. Well, I want to get this x by itself. I want the plus 5 to go away, right? It's a plus 5. There's no sign in front of it. So it's like a plus 5. The way you get plus 5 to go away is minus 5. And if I do it on that side of the equal sign, I have to do it over here. So minus 5. Now check this out. This goes away. And I don't just have x left, I have minus x. We can't just have the negative sign go away. Minus x equals 5. Now, I don't want to know the value of minus x. I want to know the value of x. So I know the opposite of minus x would be x. And if I do the opposite on that side of the equal sign, I have to do the opposite over here. So the opposite of positive 5 would be negative 5. So the value of x is negative 5. This is where checks are going to become so important. Let's check this out. Okay, I'll write down the original equation. 5 minus x equals 10. I'm going to replace the x with negative 5. Watch this. I have 5 minus, replace the x with negative 5. Now, is that true? Does 5 minus negative 5 equal 10? Well, we know 5 minus negative 5 is like 5 plus 5 equals 10. That is true. Both sides are equal to 10. That's correct. I know my answer of x equals negative 5 is correct. So, solving math equations, these are single step ones where you have to just do one thing to both sides of the equal sign. So you have an assignment today where you have to do this exact sort of thing. Make sure you do it like this. That's all for now. Flexing Teacher Weber, out.